Beginner's video. We're looking at a problem today of calculating a checksum, such as for a credit card or a tax file number. In particular, this is some Brazilian social security number. The inspiration for this came from a video I watched, an APL video. So I mentioned APL in the last video. APL literally stands for a programming language. It was devised in, I believe, the 1950s, and it's still around. The best known and technically the best instance of APL is by a company called Dialog, funny spelling, a British and Dutch company, I believe. And so they have a lot of webinars on YouTube, and I've watched two of them, one on advent of code and one on making algorithmic comparisons, like taking a checksum algorithm and making it faster. Very interesting. I'd recommend it. So there's a link there, not expecting you to copy it, but whatever, I'll put it in the description. Okay, so what are we actually doing here? So input, we've got 9 digits, and these are the digits of pi here just for fun. And then you have to apply some weights. Now, the lowest weight has to be 2, and then it just goes up to 10 in this case. Right, we'll take the inner product or the dot product. So 3 times 10 is 30, 1 times 9 is 9, 4 times 8 is 32, etc. We get the sum mod 11. Now I called that the dot product. The dot product includes the sum as well, but I'm just demonstrating the multiplication here. Then add those up and you get 189, I believe. Take the sum modulo 11, so that's 2. And then we do 11 minus the previous value, which gives us 9. So the check digit here is 9, and so then you would append that, right? You would append that, and and then in this particular case, the Brazilian thing, there are 2 check digits. So you actually now take that as your new number and do it all again, and so now the second time the check digit happens to be 0, so we end up appending a 0. So we started with a 9-digit number, we end up with an 11-digit number, where the last two, the 9 and the 0, are check digits. Right, now there's a special case. If you take the sum modulo 11, the legitimate values for that are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And what you don't want is a result of 10, because then that's 2 digits, not 1. And so there's a special case where when you do 11 minus the previous value, if you get an answer of 10 or 11, then you just convert it to 0, right? Okay, so doing this in Python or something would be very easy. There'd be some function calls, some for loops, if statement, modulus calculation. Wouldn't be very hard. The fact that you're doing it twice, you would definitely want to modularize that. We're going to look here at how to do it in Uiua. So in the previous video, I was using the online Uiua pad, which is cool. Here I'm using native installation. So just running in a text editor here. And on the left is just a terminal that's running Uiua in watch mode. So it's watching for changes. And if I've just got a little key binding where if I save it and then it reevaluates. So what I've got here so far, I've got 6 things on the stack, right? I've got a string, check digits number 1 iteration. So these are my headings. And then I've just got infinity as just a placeholder for my work, so that over here it's readable and we can see what's going on. Just to show you, if I change that to high and then save, then it gets run straight away. Okay, so let's get on with it. So we're going to start with an input. So I've got 3, 1, 4, 1, 5, 9, 2, 6, 5. And now, right, we're going in our first go at this, we're just going to do 1 iteration. So we're just going to add the 9. All right, so we need to create some weights. So if we have the input, that's on the stack, you can see over here, I'm not going to keep pointing everything out, but just to begin with, right? So I've got my input on the stack, and now what do I want to do? Well, I need to create some weights. Now they start at 2 and go up. I'm going to do the range of, well, the length of the input. So that gives me 0, 1, 2, 3, 4, 5, 6, right? And then if I add 2, then I've now got 2 to 10. That's what I wanted. And then I'll reverse. So that now I've got 10 down to 2. Right? So that's the weights that I need. And now, so I guess what I can do is now make that a real function. So I have to kind of type it all out again. It's a bit annoying, but whatever. And I'm going to got a range of the length of the input. And okay, so rerun. And I've done an assignment, so I don't get to actually see anything. And there's my weights. Okay. And so now, well, now what am I going to do? I need to get the product of the weights and the inputs. So I can do times, say the weights and the input. So we've seen that before, right? Here's our products. So they've been calculated just by using the times function. And I'm going to do a sum of those. And while I'm at it, I'll do the mod 11. Okay, so it gives me the 2. All right, and so what I'm doing in this first pass is just doing like normal programming where I assign variables. So I'm going to now type this out, mod 11 of the sum of the product of the weights and the input, and get rid of those. Put this on the stack, so just okay, so that's 2. And now I'm going to do the minus 11. So I'm going to go minus digit 11. So and okay, so now I've got my 9. Now the order here looks a bit funny. Down here, I'll just use my, I'll use this as a scratch area. In fact, I'll give it a heading. Okay, that's a silly ligature. So as a scratch area, if I go minus, minus 10, 7, like I'd read that and think I'm going to get 3, 10 minus 7, but we get negative 3. And the reason for that is it's actually pretty cool. So if I do want to do 10 minus 7, you treat minus 7 as like a function. It's not. Minus is the function and 7 is the first argument, or the first thing on the stack. However, if you mentally just think of minus 7 as a function and you apply that to 10, then you're going to get 3. Right, there you go. So the order's a bit funny, but whatever. All right, so I've now got my digit, like I've done 11 minus, but remember there's a special case where if I look at the digit and if I consider, right, is it less than 10? Is that true? Yeah, it is, right? And so you can see the result there is 1. Now the result's either 1 or 0. And so what I'm going to do is I'm going to multiply that by the digit. Now how do I multiply that by the digit? Well, I need another digit on the stack. So I mean I could put a digit there, and so I've got 1 times 9 is 9. Now better style, I'll just put a blank line here just to show we're focusing on this calculation at the moment. So I've put the digit on the stack, which is already calculated. I've said, is it less than 10? So now 1 is on the stack, and then I pop the digit on the stack again and then multiply, right? Now, if the digit had been 10, then this would be 0, and I'd be multiplying by 0, and I'd get 0. So I'm taking care of my special case, right? But this is not good Uiua style. So rather than, that doesn't need to go there. What we'll do is we'll just duplicate the digit there, okay? And so I still get my 9. Right, and so type this out again, digit equals, so I'm going to multiply by less than 10 digit. Now I know I should be doing dot, but I'm working from notes here, and that's what I had. So, right, so I'm doing, I'm not doing Uiua style programming here. And now I'm going to join the input with the digit. And here you go. You got your 314159265, which is what we had before, and then the 9 is joined on the end. Okay, so that's it for my first pass at this. All right, I've got the input up here. I calculate the weights, I calculate the digit, I recalculate the digit, I recalculate the digit, and then I join it. Okay, now we're going to try with some better code. So now I'm going to say weights is a function to produce the necessary weights array. Now I'm going for a fairly verbose comment here, but this is for absolute beginners, right? I'm an absolute beginner, so this is for me. So it's kind of nice to, excuse me. It's kind of nice to have a function to do things for you, I think. So I'm just going to, this was already like a function, but this is a calculation. But if I remove the input, now it's a function. That's pretty cool, isn't it? And I can go weights input, and I'll see the 10, 9, 8, 7, 6, 5, 4, 3, 2 on the stack. Now, someone watching a video, it's going to be a little bit difficult to maybe keep track of where the output is in the middle of this. So I think I might just do a bit of commenting, and I can comment. Okay, and we don't need to see that, I suppose. Right, I'll keep the scratch just in case. No, actually, I'm probably not going to need it again. Okay, so now it's nice and clear where to look. All right, so weights is a function. I put input on the stack, and then I call the function weights, and it takes the input off the stack, and then it puts the weights on the stack. So, all right, good. Now, what am I going to do? So, how am I going to calculate all this, right? What I'm trying to do here is to turn all of this mess, I mean, it's not bad, but to turn all of this into more Uiua-like code. So, well, we'll start with the input. And I need the weights. So that's just what I've already done. And now I need to multiply the input by the weights. So that means I need another copy of the input on the stack. And I will multiply them and run this. There we go. So what we've got here, I'll just put a line break. Right, so we're focusing on this paragraph. Right, so put an input on the stack, duplicate it, apply weights to that. So now we've got the input and we've got the weights on the stack, and then we call times. Sweet. And so now we will do a plus reduction 189. We'll do a mod 11 reduction 2. Okay, and now we want to do the 11 minus thing. So a way to do that is, well, if I did, say, put 11 on and did a minus, then I get -9 because of the order not being the right for Uiua. And so I need to change the order, so I just put a flip in there. And so now I've got my 9. Okay, and so now I'm going to ask, all right, so is this less than 10? Yeah, it is. And so I want to multiply it, but multiplying means I need two things on the stack. What do I want to multiply? Well, I want to multiply by the number that I just asked, is it less than 10? So I'm going to duplicate it here, right? So this step by step, so now I've got my 9 because I've done 9 times 1. Right, this what I'm going through here, like line by line, step by step, reevaluating and checking, it's good to like build up the intuition of what we're trying to do. And importantly, when you need to flip or you need to duplicate, like especially when you need to duplicate something on the stack, you need to think carefully about where that duplication might need to go. And a more expert programmer would be just doing this more naturally, but we're not expert programmers in Uiua. Okay, so I've done that times. And now what am I going to do? Well, I've got the 9, so I want to join that to the end of the thing, right? So if I go join, that'd be an error because there's not, right? I need more than one thing on the stack, or that's not the error it's given me. But basically, what do I want to join it to? I want to join it to the input. That means I need to go all the way back here and duplicate again, right? Because that's what I can join with, right? Now, that's put it at the beginning, not at the end, because I wanted to, like, think of the argument order. I need to flip that. So there we go. I've got the correct result. All right, and so that's my second go at this. I could type all this out in one line now. I think I'm. Should I? Okay. All right. I'll do it. All right. So we're going to. I'm just literally just starting at the bottom and reading up. Join, flip, multiply, less than 10, dot, minus, flip, 11, mod 11, sum reduction, times, weights, dot, input. Okay, so I can, there we go. We get all that. And so I can now just delete that, and there's my, all right, there's my code. So it beggars belief to me that someone can actually sit and write code like that, but maybe I'll get there one day. All right, so now for our third go at it, I'll just run this again. So we've only got the one thing on the stack. And for the sake of clarity over on the left, I'm going to comment out. So, right, we have nothing. Okay, so my third go, well, I'm going to use the weights function again. I don't need to redefine it, but I just want this to look self-contained. So weights is a good function to have. Now, we need 2 iterations, right? We've all that effort and we've like only had one check digit added, and I'm not going to write all that code again. So how am I going to modularize it? Well, I'm going to make a function, right? So, and in the spirit of keeping it all contained, I'll keep my comment there. And now I'm going to make a comment like digit is a function to produce the check digit for a given input. So that's going to basically take a lot of what we just did. We'll see if I decide to use it or if I'm going to write it. But all right, so let's think. We don't want to join, right? I'm saying that a useful unit of functionality here is just to calculate the check digit, not to do the join. That's something you choose to do after you've calculated. So let's see. If I get rid of the join and just do that times 10, then the join, if I get rid of the join, I get rid of one of these. This should give me the check digit. Yes, it does. Okay, and so I can make it a function just by getting rid of the input, right? So digit equals that. If I run this, there's nothing on the stack, but if I now run digit input, then I get my 9. Okay, so what we did is we joined, right? Now I'm going to write another function called with check digit. Oops. With check digit is a function that joins the check digit to the input. And it's not it's not hard to write this. Just excuse the aeroplane. Okay, before I'm just going to give it a dummy thing. Before I do it, let's try implementing it first. So if we have the input, and then how do we do that? We had to duplicate for the sake of a join. We calculate the digit, that calculates a digit on the duplicate, but we still have the input on the stack, and then we can flip and join, and flip and join, and that gets it right, okay? And so the with check digit is just this, but without the input. So I'm going to join, and flip the stack, digit of the input, get rid of that to make it a function. So with check digit is now a function. So whatever's on the stack, reading right to left, we duplicate, we calculate the check digit, we flip the top two elements of the stack, and we call join. And so I can test this with check digit on the input. Okay, and that's good. That gives me what I want. And so now we can easily apply it twice. So we start with our input, and we call with check digit, and we call it again because and there you go. We've got the thing that we need. All right. So, I guess we could say, Brazilian social security number or something equals with check digit. Oops. With check digit, and that's it. So we can call Brazilian social security number on the input, right? So I'll get rid of these three, and we get that. Okay, so there is a way. There is a thing in Uiua called repeat, and it's a cool little symbol with a circle with two dots above it, but I don't know how to use it, but I'm happy with this. Okay, hope you enjoyed.